Numpy is short for numerical Python. It is one of the most important foundational packages for numerical computing in Python. Numpy acts as one of the standard interface lingua francas for data exchange. By providing us with a comprehensive and well documented C API for connecting NumPy with libraries written in legacy code bases like C, C++, or Fortran, NumPy offers us a straightforward way to pass data to these libraries and then return data back in Python as a NumPy array. So, for those of you who might be wondering, well, Python is quite slow compared to C, for instance. Why does it shine in machine learning and AI? Well, it turns out that Python acts as the interface. The heavy computation are done by these libraries written in these low-level languages like C, C++, or Fortran. So here on the screen, we have a small design which gives us a little insight into the different things we can accomplish with NumPy. So we have ND array, which is short for n-dimensional array. So in Python, in NumPy, sorry, we have different arrays like one-dimension array, two-dimension array, and three-dimension array. So it says multi-dimension arrays, array index, and whatnot. We also have vectorization and efuncs. So vectorization in Python is it's a process of applying operations to entire array elements at once. So rather than using explicit Python loops to process individual elements, so by using vectorization, it gives us a faster approach of applying operations to an entire array element. We also have broadcasting. Broadcasting gives us a powerful mechanism of element-wise arithmetic operations on arrays of different shapes. You know, by we just conceptually we stretch the smaller array to match the larger array without creating unnecessary memory copies. Okay. We also have advanced features, linear algebra, random sampling, and the likes. So we're going to be looking at some of this concept in the course of our NumPy series. Now, if you wish to read more about NumPy, you can go to the NumPy documentation here. Says NumPy is the fundamental package for scientific computing in Python. It is a Python library that provides a multi-dimensional array object, various derived objects such as mask arrays and matrices and whatnot, Fourier transforms, basic linear algebra, basic statistical operations. So you can read more about NumPy in the NumPy documentation. Okay. If you're following through with this tutorial, I will assume that you have some background programming in Python. If you don't, you can check our Python beginner series on YouTube. So you can get started there. But then you have to start with Python if you wish to follow along with this tutorial series. So in any case, we need to get Python. We need to set our environment to get started with NumPy. So to do that, we have to install Python on our machine. So to install Python, okay, if you're on a Mac OS like me, you can just open a terminal here, terminal. And then if you have Homebrew installed on your Mac, so installing Python, the easiest approach, in my view, to install Python is to, let me just zoom this in, open a terminal like this. Once you have Homebrew installed, you can just do brew install Python. And then this will install Python on your Mac and then add Python to your path. Okay, so that's the easiest way to install Python on Mac in my view. There is another way we can install Python. You can go to the Python website here, and then we can download the Python installer for our operating system. So if you're downloading for Mac, you check for Mac. If you're downloading for Windows, Linux, and whatever, you can check for those and then download the installer and then run the installer. Now, for those of you on Windows, when you download the Python installer for Windows, when you run the installer, very important, don't forget to check the box that says add Python to path. So if you check that box in the process of installing Python on your Windows machine, that is going to set up, that's going to add Python to your path, so that upon successful installation of Python, you can just open command prompt and then just type Python. Then you can get your Python version there. For those of you on Windows, if you're on Mac too, you can follow this approach. You download the installer and then you run it on your Mac like we usually do. Okay, so once we have Python installed, Python is going to give us this tool known as pip or pip3 in some cases. Pip, you can think of pip as, pip is Python, what is it called? It's a Python package manager, much like NPM for Node. So once you have Python installed on your machine, you can open a terminal, a command prompt, PowerShell, whatever, and then you can just, to install Numpy, you can just do pip install Numpy. And then you press enter, and then Numpy is going to be installed on your machine. I have Numpy installed already, so I'm not going to press enter here. But if you're looking for the command, this is it. Or you can as well search the internet for for the command or whatever option is available there for installing Numpy. Okay, so that's for Numpy. Now, if you have Python installed and you do Python, you open a command prompt or your terminal like this and you do Python, you realize we're going to get a Python REPL. So this, we can use this to play with some Python code. For instance, we can do dev say I, and then here, say it's not quite what is it called? It's not quite formatting what we need here. So we can say what is it called? Print I. Okay, print I. Okay, then if you say I, if my indentation was correct, we should get I now. Okay, so this is say I. But then when you look at this, you realize it's not quite appealing. The visual is not quite appealing. So there is another way we can get okay, so this is exit. I'm gonna exit. Okay, so there's another way we can get a better Python interpreter. So we could install IPython. So if we to install IPython, we can install IPython with pip. So IPython is an integrated Python shell. So it just gives us a better outlook So we can do pip install IPython. So just press enter. It doesn't matter whether you're on Windows or Linux. So once you have your command prompt or terminal open, just do pip install IPython, press enter, and then IPython is going to be installed on your machine. So once you do that, just open your terminal again and then just type IPython. And this is going to boot up the IPython integrated shell. So you see, this look much better. So if we try to re-implement what we did the other time, so say hi, you see this, you see the indentation works automatically here. I didn't have to use tab or space or anything. So I can just do print hello Python, hello Python. Okay, so press enter, and then here we can invoke this function. Then it says hello Python. So you realize this looks much better than the native Python interpreter. So you can use pip to install IPython, and then we're gonna be using IPython to run our Numpy tutorial series for our coding examples. Okay, so there is another way we can get Numpy and IPython setup. You can go to Miniconda. So you can install Miniconda. Miniconda is a minimal installer for Conda that includes only Conda, Python, and a small number of essential packages. So if you install Miniconda, you don't even have to install Python. Like it says, it's shipped with Python and a small number of essential packages. So those essential packages includes IPython, even Numpy. So once you have Miniconda installed, that's all you have to do. You don't have to install IPython. You don't have to install Numpy. You don't even have to install Python. So you have this installed. You open up a Miniconda shell, and then you just press IPython. You type IPython, and then you press enter, and then we have what is it called? You have an IPython shell to work with. And then if you want to go for a larger distribution, a larger Python distribution, this is it, Anaconda. So it's a Anaconda shipped with Python, Jupyter, and thousands of data science packages in one step. So to install this, I say if you go down here, it says Conda Package and Environment Manager, Jupyter Notebook and Jupyter Lab, desktop app, navigator, command line interface, works on Windows, Mac OS, and Linux. So if you wish to install this, you have to get started. Getting started, you have to register with your email before you can access the download page. So if you set this up, you don't have to install Python. You don't have to install IPython. You don't have to install Numpy or Pandas, whatever. Anaconda is shipped with all of those. So once you have this, just open the Conda command line interface, and then you can press type IPython, and then press enter, and then you should be greeted with an IPython integrated shell like this. So this is where we're going to be writing our NumPy programs for this tutorial series. So guys, this is just a small introduction to our NumPy tutorial series. So I hope to see you in the next video. Okay, thanks for watching.